Welcome all of you to another video of Maths Made Easy. I'm taking up 9th CBSE Chemistry first chapter today, that is matter in our surroundings. So let us first see what is matter. Okay, what is matter? You have done it in your earlier classes also, in 8th standard also. Here once again we are going to take up what is matter. Okay, so matter is made up of, matter exists in three states. One is solid, one is liquid, and the other one is gas. Okay, now matter exists in these three states. Now in solid we know that the particles are very close by, very close by. In liquids the particles are little far away. Okay, and in gases the particles are very far away. Okay, so in solid the particles are very close. That means the intermolecular forces of attraction is very high. That means one molecule is attracting another molecule with a lot of force. They are very closely attracted to one another. The same thing here is little less. So the intermolecular force of attraction is little less for liquids and least for gases. That is why gases can stay far away. Okay. Now, when we heat a solid, the particles gain a lot of kinetic energy. Okay. The particles gain a lot of kinetic energy. Now, each particle starts vibrating in its position. Because of increase in kinetic energy, it will vibrate in its position, and once it vibrates in its position, the particles break the intermolecular force of attraction and they move away from one another. So when we heat solids, the intermolecular force of attraction is reduced and they move little far away, forming liquids. Further we heat liquids, intermolecular force of attraction is further decreased and the particles further move away, forming gases. So kinetic energy of particles is highest in gases. Okay, so kinetic energy is highest here. Now if we talk about solids, it is not compressible at all. Solids, this is most compressible. What is the meaning of compressible? That is, you can press it down and reduce its volume. Here this is less compressible than that of liquids, and this is the least compressible. Okay, this is the least compressible. Solids is the least compressible. You can press it down, but you will not be able to change its volume. Okay, then let's come to another thing, that is what is the volume of a solid. Solids have, so the volume of solids is it is a very rigid structure. It will not change its volume. Liquids also have a fixed volume. Liquids also will have a fixed volume, but then it will take the shape of the container. Volume is fixed. Okay. Gases, they don't have a fixed volume also. If they get more space, they will spread out more. Okay. So that is, gases have no fixed volume, no fixed shape. Okay, they will, you keep it in a container, they will take the shape of the container. Otherwise, and if they are in open space, they will just spread out. Okay, so that is, this is rigid. Fixed volume takes the shape of the container, fixed volume again. Here no fixed volume, of course, takes the shape of the container. Okay, now let's come to the change of state. Solid to liquid is melting, you know it. Okay, also called as fusion. This you have learned in your earlier classes. Now liquid to gases is vaporization. Okay, liquid to gases is vaporization. If I want to take a solid straight to the gaseous form, there are certain solids which go straight from solid to gaseous form. Okay, solid to it goes straight from solid to the gaseous form. Okay, there are certain solids, then it is called sublimation. Okay, it is sublimation. And if it is going from gaseous form to solid form, then it is called deposition. Okay, this is, then it is, so from gaseous to solid form, this is deposition. Okay, so these are the few changes in state and their names. So this, now let's come to what are the different substances that are sublimables. What are the different sublimable substances? Okay, so there can be many substances. I'll just give you 4 examples which you get to see in daily life. The first one is iodine. Okay, iodine is grayish, gray, purple, okay, colored crystals. So it is a non-metal. Iodines are gray, purple colored crystals. Let's come to the other one, which is after iodine, I have naphthalene. Naphthalene. Now naphthalene is white colored balls which you put in your wardrobes to keep away worms. Okay. Third one, they smell very nice. Okay. Third one is after iodine, you have dry ice. Dry ice is light pinkish. Okay, very light pinkish colored ice. Okay, they look like pink colored ice, and they are solid carbon dioxide. Dry ice is solid carbon dioxide. Okay, so solid carbon dioxide is a gas and you solidify it, and for certain purposes we use it for freezing purposes, especially on ships. Okay, so this is used for solid carbon dioxide because it is sublimable. It is helpful in ships. Then next is ammonium chloride. Now you might not have seen this ammonium chloride. This is something you have not seen. You have not seen ammonium chloride called NH4. Formula is this. It is white, just like, you know, it just looks like white powder, looks just like salt. So if you don't know, actually you can actually think it is our table salt. So these are the 4 sublimable solids. So one experiment that is done with iodine is we take a funnel and we keep a petri dish here, we put some iodine crystals and then we heat it. Okay, we heat the iodine crystals. What happens is all the iodine vapors, they go and condense in this part of the funnel. They go and condense here. So first it will vaporize from here on heating, no liquid formation. That is why it is called sublimation. And then it goes and deposits over here. Now this is called, first vaporization is called sublimation, and when it settles down, once again condenses, it condenses here because these are the colder parts of the funnel. This part of the funnel is warmer, here it is colder. So it solidifies there and settles down as powdery iodine particles. Now you want the iodine back, you will have to scrape out the funnel and you get your iodine back. So this is an example of sublimation once again. Okay, so now in this chapter there are a few important words that you need to remember. So here one word is diffusion. Okay, diffusion. What is diffusion? Now diffusion is you are opening a bottle of perfume at one end of the room, and standing at the other end of the room you start smelling it. That is diffusion. How did the particles reach your nose? It reached your nose by the method of diffusion. Now diffusion of intermingling of different types of particles. Okay, intermingling of different types of particles. Types of particles is called diffusion. Intermingling of different types of particles is called diffusion. Okay, so diffusion is, now here you will say, if I am talking about a perfume bottle, what is intermingling? The air particles in the room with the particles of the perfume, that is intermingling. So they can ask you the definition for this. Okay, what is diffusion? It is intermingling of different types of particles is called diffusion. Okay, now the next thing that is very important in this chapter is evaporation and boiling. Okay, Now, what is the difference between evaporation and boiling? Evaporation is uh, something that, supposing you have a bulk of some water in a bucket, okay, and slowly the top layer of water gets, you have let it out in the open, the top layer of water is getting enough energy, getting enough kinetic energy because of the heat. It is getting enough kinetic energy to pull itself out of the intermolecular forces of the water, of the other particles of the water, so they can just move out, forming water vapor. Now the next layer again gets heat and it gets enough kinetic energy to move out of the uh, water, okay, as vapor. Like this, one by one different layers of water keep moving out. That is called evaporation. Whereas in boiling, we have to keep whatever, a beaker full of water, we start heating it on a stove, and we see that if it is made out of glass, there are bubbles all through it, okay. So when we see bubbles all through, it is boiling all through the liquid. So when it is boiling all through the liquid, we know that boiling is a bulk phenomenon. Okay, this is a bulk phenomenon, whereas evaporation is a surface phenomenon. Means evaporation happens only from the surface and boiling happens throughout. Okay, the second point is, you'll see that evaporation is a slow process. This is a slow process, whereas boiling is a pretty fast process. Now supposing you have poured some water on the floor at night, and in the morning you come and see that the water is not there. Okay, that means it has evaporated overnight. How did it happen? Because it happened like this, because it is, when it has evaporated overnight, that means now you can't say that the temperature has gone up to 100 degrees centigrade any time in the night. No, the temperature didn't go till 100 degrees centigrade. It was at room temperature only. But the entire water evaporated at room temperature. Okay, so evaporation can happen at any temperature, whereas boiling has to happen only at boiling point. Okay, at boiling point. This happens only at boiling point. So that is the difference between evaporation and boiling. Now we will see few factors on which evaporation depends. Factors on which evaporation depends. Now what are the factors on which evaporation depends? Firstly, the factors. The first one is the temperature. If the temperature is high, evaporation is high. On a hot summer day, evaporation is very fast. If the day is windy, okay, even if the temperature is little low, you will see that the clothes are drying fast. So wind makes more the wind, more the drying, more the evaporation. Then the third one can be the humidity. Now humidity affects evaporation, means more the humidity, less the evaporation. So you will see in a rainy day, clothes are not drying fast. Okay, now in a humid day, even if if during the winters temperature is little low, but if the air is dry, that is less humidity. In winters generally humidity is less. Okay, then clothes will dry fast. Even then, even though the temperature is low. Okay, so humidity is one thing that reduces the rate of evaporation. Then comes the surface area. Okay, more the surface area, more the evaporation, clearly. So higher the surface area. So we always say spread out the clothes to dry. Okay, you have to spread out the clothes to dry so that it dries faster. Okay, or you will see people pouring their tea on a saucer and then drinking to cool it faster, because evaporation will cause cooling. Okay, so these are the four factors on which evaporation depends. Now if they ask you, you will have to say wind, more the evaporation, more the humidity, less the evaporation. How it depends on this factor, you will have to tell. Now let's come to one very important thing in this chapter, which is latent heat. Okay, latent heat. Now what is latent heat? Okay, firstly, what is the meaning of the word latent? Latent means hidden. Okay, hidden heat. Now what? Supposing I have ice at minus 10 degrees centigrade. I have ice at minus 10 degrees centigrade. Now I am heating it. A time comes when the ice reaches 0 degrees centigrade. Okay, I am still heating it. Remember, ice in cold countries, it will be at minus 30, 40, 50. Okay, so those ice, they take a lot of time to heat and to melt. So here, now it is 0 degrees centigrade. It has reached. Once it has reached 0 degrees centigrade, now you are still heating it. Now this ice is converting to water. Now if you place a thermometer in this ice now at 0 degrees centigrade, when it has started being 0 degrees centigrade, you have placed a thermometer in it, you will see that the temperature is not increasing till all the ice has got changed to water. So temperature remains 0 degree as long as even little bit of ice is left. During the entire duration of change of state from solid to liquid, the temperature remains the same. And then you start, once it has entire ice is now water, now the temperature changes and it starts increasing. Now it reaches 100 degrees centigrade and you are again heating the water. You are again heating the water. Okay, you are heating the water till so that it is finally, okay, you are heating the water. Now when you start taking the temperature of 100 degrees centigrade water, first it boils till the entire water does not change to vapor. The temperature of the water remains 100. Okay, when the entire water has changed to vapor, then it changes to 101, 102, like that. So what we learn from this is, whenever there is a change in state, not only, I'm not saying only for water, it happens for all elements, all things. Okay, whenever there is a change in state, there is no change in temperature, and the heat absorbed when this state was changing from ice to water, this change of state was happening. Okay, during the entire duration during which change of state was happening, that is called latent heat of fusion. That is, during this part, the melting part, it is latent heat of fusion. Here this is latent heat of vaporization. Okay, this is latent heat of vaporization. So this is latent heat of fusion when it is melting, the heat absorbed when melting. The heat absorbed when it is changing to vapor is latent heat of vaporization. Okay, so these are the two latent heats. Now sometimes they also use one word, specific. Okay, they use a word specific. Now when they use the word specific, it means the amount of heat absorbed by 1 kg or 1 gram. In CGS 1 gram, in SI 1 kg of the substance while melting is called the specific latent heat. Here we will not talk about temperature because the temperature remains the same. So latent heat of fusion is the amount of heat that is being absorbed while melting. Specific latent heat is the amount of heat absorbed while by 1 kg or 1 gram while melting. Okay. Now let's come to few give reasons. Why do people wear cotton clothes? Cotton clothes in summers. Okay. Now why do people wear cotton clothes in summers? Okay. Now cotton has pores in it. Now this cotton will absorb our sweat in summers, and the sweat, when it will evaporate, the sweat will evaporate from the clothes and it will cool our body, because evaporation causes cooling. Evaporation causes cooling. Now why does evaporation cause cooling? When this sweat is evaporating, okay, anything is evaporating, anything. Just now we saw latent heat of vaporization. So this water, when it is evaporating from our clothes, from our body, it is taking the latent heat to evaporate from our bodies. Okay, and so our body cools down. So we feel better. Same thing happens. Why do people drink water from earthen pots. Earthen pots in summer. Okay, why do people drink water from earthen pots in summer? People drink water from earthen pots because these earthen pots will have small pores. Now, when you pour water into the earthen pots, what happens is the water seeps out. The water seeps out. This water, the droplets of water which seep out, will evaporate. And when it evaporates, it takes the latent heat of fusion, from latent heat of vaporization, sorry, from the water becomes cold. Okay, so naturally water becomes cold. So faster the evaporation will happen outside, more the water will become cold. Okay, another thing, if you ever seen that you put little bit of perfume on your hand, on your skin, and you feel little cold in that area till it is wet. Once it evaporates, you don't feel cold anymore. Same reason, the perfume is evaporating from your hand, taking the latent heat of vaporization from your hand, and that is why you are feeling cold. Okay, that is why your that portion of the skin feels little cold. Okay, so these are few of the examples of latent heat of vaporization. When you write these answers, you will have to talk about latent heat of vaporization. You have to even give this line: evaporation causes cooling. Okay, so whenever there is evaporation, there is cooling. There are summer coolers people use when in the peak summer season. People will use summer coolers. Now, what is that? That is, they have a box kind of thing. They'll have a box kind of thing with a fan attached here, and they'll have a mat which is made wet. Now, what happens as this fan is switched on? This mat, the water from the mat evaporates because of the wind of the fan, and all the latent heat of vaporization for this water to evaporate from this mat is being taken from the room. The room cools. Okay, so that is what is a summer cooler, not an AC. Okay, AC is a different thing. Now we need to talk about absolute temperature. Now, what is absolute temperature? Supposing you have a cylinder of gas with you, nitrogen gas with you. Okay, you have a cylinder of any gas with you, and you are trying to cool it. You are constantly trying to cool it. So how does one cool it? Means cooling is taking the heat out, because we don't put cold, we take out heat energy. So we are constantly taking out heat energy from it. Okay, then the temperature goes down. As we take out heat energy, the temperature goes down. A time comes when there is no more heat energy left in it. Okay, and that happens when the temperature has gone down to minus 273 degrees centigrade. At this point, there is no more heat energy left. This is called the absolute temperature, and this is where 0 Kelvin, okay, 0 Kelvin, okay, this is where the Kelvin scale starts. This is where the Kelvin scale starts. Okay, so minus 273 degrees centigrade, this is where the Kelvin scale starts. So this of the Kelvin scale, this is 0. So if we say absolute temperature is minus 273 degrees centigrade in centigrade scale and 0 degree Kelvin in Kelvin scale. Okay. Now let us talk about the different scales of temperature. Okay, because you get small numericals in this. If I talk about centigrade scale, I have 100 degrees centigrade, which is the boiling point of water, 0 degrees centigrade, which is this is the centigrade scale. Okay, this is the centigrade scale. Okay, this is the centigrade, 0 degree and 100 degree. If I talk about the Fahrenheit scale, in Fahrenheit scale, the 0 degree, the condition of heat at 0 degree is same as the 32 degrees Fahrenheit. Okay, and the 100 degree, that is the heat condition at the boiling point of water, is 212 degrees Fahrenheit. Okay, when we measure fever of the human body, it is in Fahrenheit only. So 212 minus 32, okay, that is 180. So 180, if this is distributed in 100 parts, Okay, here there has to be 180 parts for, I'm talking about graduation. That is how many, if I split it into here to here, after this 33, 34, 35, like that, if I want to reach to 112, I need 180 parts here. Here I need 100 parts. Okay, but the difference in heat is same as here and here. So if in Fahrenheit boiling point of water is 212 and freezing point of water is 32 Fahrenheit. Okay, let's talk about the Kelvin scale. Now Kelvin scale is here. This is, now our 0 degree centigrade becomes 273 Kelvin. Now for Kelvin we don't put a degree, okay, because minus 273 degrees centigrade was 0 Kelvin. Okay, so 0 degree centigrade is 273 Kelvin. Okay, and here it is 373 Kelvin. Here I can cut it into 100 parts. Okay, so boiling point of water in Kelvin is 373 Kelvin. And this Kelvin, okay, the Kelvin scale is the SI unit of temperature. Okay, this is the SI unit of temperature. So we always measure it in Kelvin. Now what kind of sums will come for you? Sums, very simple questions on conversion of centigrade to Kelvin, Kelvin to centigrade. Okay, so I can clearly see 100 degrees centigrade is, if you want to convert to 100 degrees centigrade, you want to convert to Kelvin, then you will have to add, okay, 100 degrees centigrade is, you have to add 273 to it. So any temperature in centigrade, you will have to convert to Kelvin, you will have to add 273 to it. Okay, because Kelvin starts 273 positions below this. Okay, so we'll do few sums and Kelvin to centigrade you'll have to subtract. So here let us do few sums of this kind of conversions. Here 300 Kelvin, okay, Kelvin to centigrade I have to change. So I'll have to subtract. So here it is 300 minus 273, which becomes 27 degrees centigrade. Here if I subtract 273, I get straight away 300 Kelvin. Okay, I get 300 degrees centigrade. Here if I subtract 273, how much do I get? I get a 20 degrees centigrade. Here if I get here, so I get a 197 degree centigrade. Okay, all you have to do is subtract 273. Here add 273. If you add 25 plus 273, you'll get 298, okay, Kelvin. So here if I add 273, how much will I get? I get a 646 Kelvin. Okay, don't write degree Kelvin. So these are few of the small numericals that can come in your exams. Now there is one question. What is the physical state of water? Physical state of water at 100 degrees centigrade. Physical state of water at 100 degrees centigrade. The physical state of water at 100 degree, think little. Okay, what should it be at 100 degrees centigrade? It can be at 100 degree, physical state of water will be a mix of water and vapor. We can't say physical state of water is only water or only vapor at 100 degree, because if you are converting at 100 degree, both can exist, water and vapor. Same thing at 0 degree, water and ice. Okay, so that was it in this chapter of matter in our surroundings. It is a small chapter. Okay, so go through the chapter well, read the question well. Any doubts you can ask in the comment box. Okay, keep watch on the playlist. I shall be uploading many more chemistry chapters now, one after the other. Also, if you have not subscribed, please subscribe without fail, because many more chapters will be uploaded very soon. Okay then, thanks all of you. Bye then.